just a couple additional comments about about using these tools moving forward. Any source file containing CUDA language extensions must be compiled with NVCC, NVIDIA C compiler. And this is actually a source code, essentially almost like a source code, filter kind of thing, or compiler driver. And it works by invoking all the necessary tools and compilers like CUDA ACC, which is compiling assembly code, or GCC, C++, all these things. Why? Because what happens is if you have a code, a piece of code with they will essentially extract all the device code and then finish the compilation of that device code through the NVIDIA specific compilation phases. However, it will also use either the GCC or the Intel compiler or whatever compiler that you choose to invoke on the other side to compile the host side code. It should be compatible with pretty much all the compilers that you can use on let's say a PC. Okay, and MVCC can output either C source code that then compile with the rest of the application using another compiler, or object code directly. In some cases there's a preferred path. If you don't specify at all, it's going to fall back to a default compiler and finish the compilation into object code even on the host side. Linking. Any executable with CUDA code requires two dynamic libraries. And the CUDA runtime library and the CUDA core library. And these things should be pretty much taken care of for you at this point. But in earlier times, sometimes people get really confused because they try to link it and they couldn't link it and they didn't realize that they're missing two libraries. So we always talk about it, but it should be less and less relevant these days. Debugging, okay? You're going to be debugging, okay? So this is the fun part of the course. You're going to be debugging, right? So an executable compiled in device emulation mode, which is what you used for MP1, okay? Runs completely on the host using the CUDA runtime, okay? So there are two things about it. One is there's no need for any device for CUDA driver. So even if you don't have the CUDA card, even if you didn't install the CUDA driver, the code runs. Okay, it's self-contained. Okay, it just only runs on the host. And each device thread is emulated with a host, essentially a P thread. Okay, so in many ways, it's kind of it still gives you some parallel execution behavior because it generates a host thread, but the parallel behavior may not even be any way similar to what's actually executing on the hardware, right? The level of overlap and all that. And there are also some subtle things. When you're running in the device emulation mode, you can use host native debug support, breakpoints, inspection, and so on, GDB, and pretty much anything you want, which is great. Okay, you can set breakpoint, you can single step, great. However, once you finish debugging, or if you start to run it on hardware, most of those things don't work anymore. Okay, there are additional support that is being added to the future, chip implementations that will eventually support GDB and so on, but not in time for you this semester. Okay, so it may be advantageous for you to still use the emulation mode even with hardware access, so that at least you get most of the the sort of the software bugs out of the way, program logic kind of thing out of the way before you start to run on the real hardware. Okay, so that's the point that the point of talking about this. And access any device-specific data from host code and vice versa. Essentially, when you use the emulation mode, your host code can actually read and write device data. Okay, but not in the real hardware execution. Okay, so if you get away with, if you get confused and started to write code that actually read and write a device data directly in source code, you may not be able to find it when executing in the emulation mode. It will just let you do it, right? But it's bad news when you start to run it on the real hardware. Okay, so that's another caveat that you need to keep in mind. You can call any host function from the device code. So, if you have a kernel that has 256 threads per block and, thousands of blocks, all of them can call printf, okay, when you do the emulation mode. But as soon as you move it into real hardware device, it's going to crash. It's going to just break, okay? So, if you have any printf statement and so on left in your kernel code from debugging in the emulation mode, get rid of them before you go to the host, go to the real hardware, right? And then detect deadlock situations caused by the improper usage of sync threads. This is a lot easier to find when you execute on the emulation mode because you can manipulate these things a lot easier. You can use debuggers and so on. But once you get onto the real hardware, it becomes several times harder to find it. So, that's why, what I always advise people is, don't be too clever about using these sync threads. Just use them on non-controlled paths, okay? If you have to use it, use it with caution. So let me give you this little story as to end the lecture today. There was one day, when a friend of mine went to went into a up and rising country. They used to call these, third world countries, but let's call them up and rising countries. So, the host told the guest that whenever you go through a signal, a traffic signal light, there are different ways of reading these lights in our country compared to yours. And the guest says what? It says, first of all, you don't need to be, you can actually drive color blind in this country because those three lights are all the same thing. They all mean proceed with caution, right? So, the guest, being from a, over the hill country, didn't really believe that. So, it says, okay, I'm going to be really cautious about this, right? So, red light, the guy stopped. And then sure enough, all the drivers behind the guy, got really angry because they almost rear-ended the guy, right? It's really dangerous if you stop, in front of the red eye, because of people behind you, right? So he learned and said, okay, now I understand. So I'll proceed with caution, whenever there's a red light. And then, the second day, he went driving and he got hit by another car because, there was a green light. He forgot that green light also means proceed with caution, right? So he got hit by the other direction. So what's the moral of the story? The moral of the story is, if you really want to use sync args in control constructs, proceed with caution in any situation, okay?